Hi everyone, I'm going to discuss the types of systems of linear equations in two variables. So in this discussion, I'm going to concentrate on the properties of each type of systems of linear equations in two variables. Now, a pair of linear equations of the forms a sub 1 x plus b sub 1 y equals c sub 1 and a sub 2x plus b sub 2 y equals c sub 2. These two equations class form linear equations, systems of linear equations such that a, b, c are constant terms and x and y as the variables. Now, a solution to that system is an ordered pair, which is represented by the coordinates x, y, that would satisfy to both of those equations. Now, the set of all solution is the solution set of the system. Now, not every system of equation has one ordered pair as its solution. Some systems have no solution, others have an infinite number of solutions. So, in the next slide, I'm going to present each pair of systems of linear equations, and then we're going to describe each pair by sketching the graph, and then later I will summarize the properties of each system of linear equations. So to begin, let us sketch the graph of this pair of linear equations. So you know how to graph a line using the different methods. But for easy graphing, I already converted each linear equation here into its slope-intercept form. So we can identify easily 2 points which will determine a line. So for instance, in the first equation, we know that the constant term is the y-intercept, and with that, we are able to identify 1 point from that equation, which is 0, 3, and we will be able to identify the other point by working on the slope of the first equation. Likewise, for the second equation, the y-intercept is 5 halves, so we already have 1 point, which is 0, 5 halves. And then we will make use also of its slope, which is equal to -1/2. So plotting 0, 3, and then considering the slope -1, so we will move down by 1 unit and then run to the right by 1 unit. So we are able to identify 2 points from the first equation and then connect the 2 points. So this is class the graph of y equals -x plus 3. So about the graph of the second equation, let's make use of another color. This time, let's make use of red. So we have 0, 5 halves. So 0, 5 halves is somewhere in between 2 and 3 here. And then -1/2. So we will move down by 1 unit and then run by 2 units to the right. So this is the other point. Okay. So connecting the 2 points. So connecting the 2 points, we have, okay. So as you can see, the two lines intersect. So how about this pair of linear equations. So this one has 1 point at 0, 3 because 3 is the y-intercept, and we can make use of the slope negative 2 to plot another point, and then we can simplify the second equation by dividing both sides by 2, and we'll come up with y equals negative 2x plus 3, which is exactly the same with the first equation. So that would mean that the two equations are equivalent. If that's the case, then both of these equations would have the same points and would have the same line. So, for example, if we're going to plot 0, 3, and then from the slope negative 2, so we will move down by 2 units and then run by 1 unit. So, this is the other point. Connecting the 2 points, we'll be able to sketch the line represented by the first equation as well as the second equation, since the two are equivalent. So we can say that the two lines class coincide because they are equivalent. And for this last pair of linear equations, now this one is supposedly y equals 1 half x minus 5 halves. So they've got the same slope. So from the previous discussion, we know that um, parallel lines have the same slope. So we can we might consider that the lines will be parallel lines, but let's find out if really the two lines are parallel, and we come up with that idea since they've got the same slope. So what we will be doing is to sketch the graph of each equation using the slope intercept form. So the y-intercept of the first equation is at 0, negative 5 halves, since the constant term is negative 5 halves. While for the second equation, we have 0, negative 1. And then the slope of each are the same, like m equals 1 half here and m equals 1 half here. So plotting 0, negative 5 halves. So 0, negative 5 halves is in between negative 2, negative 3. So this is 0, negative 5 halves. And then using the slope, um, rising up by 1 unit and then running by 2 units to the right. So this is the other point. So connecting the 2 points, so we have this as the graph of the first equation. So this is y equals 1 half x minus 5 halves. And then for the second one, we have 0, negative 1, which is somewhere here. And then the slope again is 1 half. So we will move by 1 unit up, run by 2 units. So this one. So really, the two lines are parallel for the second pair of equation. Now, let us summarize each pair of linear equations that we have graphed using this one. So the first one, the first pair of equation that we have graphed is, or the two lines intersect. And we call that system, we define that system as consistent and independent system. Now, a consistent and independent system has a solution set which is a unit set. So, the solution set is a unit set, And the solution is actually their point of intersection. And then the lines intersect. Now, the second pair of equations that we have graphed is defined as consistent and dependent system. Now, their lines coincide because the lines or the two equations are equivalent. And then the solution set is infinite, which is represented by the points on the coinciding lines. And then lastly, this system is called as inconsistent system. So the lines are parallel. The solution set class is empty. Now, recognizing the different kinds of systems class allows us to know the number of solution to a particular system. And then this table would show the summary of each type of systems of linear equations. So we have consistent and independent. Their slopes are not equal. Their y-intercepts may be equal or not equal. Their graphs intersect. And then look at the ratio with respect to the numerical coefficients of x and y and the constant term. So the ratio between a sub 1 to a sub 2, b sub 1 to b sub 2, and c sub 1 to c sub 2 are not equal. And take note that consistent and independent system has one solution which is the point of intersection of the two lines. Now we have inconsistent, their slopes are equal because the lines are parallel, and then their y-intercepts are not equal. A sub 1 over A sub 2 equals B sub 1 over B sub 2, but not equal to C sub 1 all over C sub 2. And with that, an inconsistent system has no solution. Next is consistent and dependent system. Their slopes and y-intercepts are equal because the two equations are equivalent, and the graph will coincide. As regards to the ratio, a sub 1 all over a sub 2 equals b sub 1 all over b sub 2 equals c sub 1 all over c sub 2. And the solution set is infinite, which is represented by the points on the coinciding lines. Now, without graphing class, we can identify as to each system is consistent and independent, inconsistent, or consistent and dependent. So with the previous examples that we have used in this discussion, so the first pair is x plus y equals 3. So I already placed or converted this into standard form so we can identify easily what's A, what's B, and what's C. Like for the first pair of equation, working on the ratio, this is 1 all over 1, which is not equal to 1 all over 2, which is not equal to 3 fifths. So that's why this is considered as consistent and independent. With the second pair of linear equations, we have 2x plus y equals 3. We have 4x plus 2y equals 6. So the two are equivalent equations. So we come up with equal ratio from a sub 1 to b a sub 2, which is equal to b sub 1 all over b sub 2, which is also equal to c sub 1 all over c sub 2. So this is considered as consistent and dependent system. And the third example, you have x minus 2y equals 5, 2x minus 4y equals 4. So we have 1 half equals 1 half, which is not equal to 5 fourths. So we consider this as inconsistent system. So in our next discussion, we're going to calculate on the solution of each type of system, consistent and independent, inconsistent and consistent system. So bye for now.